How's it, grade nines? Today we're going on to congruent triangles, working from slides 18 to 28 from the similarity and congruency PowerPoint. Okay, so let's get some definitions out of the way first. So, two triangles are congruent if they are equal in every respect. In other words, they are identical. So you saw with similarity, you had a bigger triangle and a smaller triangle, and they were similar. Their angles were exactly the same, but the lengths of their sides were either longer or shorter. For congruency, on the other hand, their lengths of their sides will be exactly the same. Their angles will be exactly the same. In other words, they will be identical triangles. Okay, and that's what congruency means. They are exactly the same. They have the same shape and the same size. They are the same shape essentially. Okay, then this little sign over here with the three lines going like this means is congruent to. So if we have a look back here, the three lines going down means similarity, and then the three lines going across like this means congruency. Okay, so those are just some things that you need to know. Now, in order to prove congruency, we have four conditions, okay? Whereas similarity, you only had the two. It was angle, 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 or sides in proportion. For congruency, though, we have the four, all right? And the four conditions we are going to go through now. So condition one. Condition one is if you can prove side, 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 all right? So if you look at this triangle PQR and this triangle KLM, you can see that PQ is equal to KL. That's what those little lines mean there. So PQ equals KL. You can also see that QR equals LM. That's what those three lines mean there. And then PR equals KM. That's what those two lines mean. If you prove it this way, then triangle PQR is congruent to triangle KLM, and your reason is SSS. You proved it using side, side, side. Condition two is, now I just need to give you a little warning about this one. If we have a look here, we've got PQ equals KL. That's what that line means, and that line means there. We have QR equals LM because of that three lines there. Then we have this angle Q equals this angle L, okay? And what I want you to notice from this grade nines is this angle is the inclusive angle. In other words, you've got to have your two sides like this, and it's the angle between those two sides, okay? You can't have that this angle equals this angle, and then those two sides are equal, because this angle here is not the inclusive angle of the two sides. So that is the important thing for this condition number two. This angle needs to lie between the two sides that are equal. If you have that, and I've just shown you that they're equal, then triangle PQR is congruent to triangle KLM. And our reason is SAS, side, angle, side. And the angle is the inclusive angle. So just put a very big NB here, that the angle needs to be the inclusive angle of the two sides. Okay. Going on to condition three. Condition three is if we can prove angle, angle, side. So if we have a look here, we're given that QR is equal to LM. QR is equal to LM. Then angle Q is equal to angle L. They both have those little stars. And then angle P is equal to angle Q. Then we can say that triangle PQR is congruent to triangle KLM. And our reason is SAA. Side, angle, angle. All right. This does not have to be an inclusive angle because we only have the one side. Then condition four is RHS. Now what RHS stands for? It stands for right angle, hypotenuse, side. Okay, so this will only work with a 90-degree triangle. So if we have a look here, we have angle Q is equal to angle L, which is both 90. Then we have, now I just want to show you where our hypotenuse is. Your hypotenuse is always the side opposite the 90. So this PR is your hypotenuse. And for this one, your KM is the hypotenuse. So this is the one I'm looking at here. So we've got that PR is equal to KM. That is your hypotenuse. Then we just need another side. It doesn't make a difference if it's this one and this one, or this one and this one. If you can prove that, then you have RHS. So in this case, QR is equal to LM. Therefore, triangle PQR congruent to triangle KLM. And our reason is we have our right angle, we have our hypotenuse, and we have another side. So it's RHS. Okay. Right, grade 9s. Let's go on to some examples. So example 1 is asking us to prove that triangle RPQ, this one over here, is congruent to triangle SQP, this one over here. Okay. So what I'm going to do is just it's the same as similarity. I'm going to say in triangle RPQ and triangle SQP. Okay. We need 3 things. The first thing I'm going to say is RP is equal to SQ. Okay, that was given to us. So RP lies in this RPQ triangle, RPQ. So we have RP equals SQ. And our reason for that was it was given to us. For number 2, I'm going to say that RQ equals SP. And the RQ side lies in this RPQ triangle. So RQ equals SP. And that was given to us. Then, what I want you guys to note here is so far we have a side and a side. Okay? So if I go back to our reasons here, or our conditions, we've got a side, so it could possibly be condition 1. We've got a side, it could be possibly condition 2. We would just have to prove another angle. It can't be condition 3 because we've already got 2 sides, okay? So this one is out. And it can't be RHS because we don't have a 90-degree triangle. So it's either condition 1 or 2. Now, having a look at it, it's going to be very difficult to try and prove an angle. So I'm going to ignore condition 2 and see if I can use condition 1 and get SSS. We've already got the 2 sides. And if you notice here with this triangle RPQ and SQP, they share this common side, which is PQ. So we have that PQ equals PQ. And our reason for that, it's common. It's a common side for both triangles. And this was another side, okay? And you can see there, I have proved it using condition 1. Side, side, side. All right, so therefore, now this is where it becomes a little bit different from similarity. I can't read down like I did with similarity. So I'm going to use how they gave it to me here. So therefore, triangle RPQ congruent to triangle SQP. And our reason for that, as I put here, is side, side, side. Okay, let's go into example 4. So example 4 is saying prove triangle CED congruent to triangle GEF. So we have the CDE triangle and this GEF triangle. So how do I start this off? We say in triangle CED and triangle GEF. We need 3 things for congruency. Okay. So the first thing I'm going to say is that this side CE is equal to this side GE or EG. Okay, it was given to us. Now CE lies in the CED triangle. So we have CE is equal to GE. And that was given to us. The next thing I'm going to say is this ED or DE is equal to FE. that was also given to us. So we have here DE equals FE, and that was given. And what I want to do now is I just want to, just so I know which condition that I'm using. So this was a side, this was a side. So if we have a look, we have two sides. I can possibly use condition 1. I just have to prove another side. Possibly condition 2. I'll just have to prove an angle. It can't be condition 3 because I've already got two sides. All right, here we need two angles. And it can't be condition 4 because we don't have a 90-degree triangle. So let's see if we can maybe prove another side. Well, we proved this side and this side is that side and that side. It's going to be difficult to prove that this side is this side because we don't have any information. But maybe we can prove an angle. And having a look here, we've got this E1 would be E2. E1 would be equal to E2. Why? Vertically opposite angles. Okay, so this angle E1 lies in the CED triangle. Angle E1 equals angle E2, and E2 lies in this EFG triangle. And our reason for that is vert op angles. Now, remember what I said about this condition 2, and this was the important thing. Your angle that you proved needs to be the inclusive angle. In other words, the angle needs to be between the two equal sides. Let's just see if that holds for our triangle. Well, we've proved that this side and this side is that side and that side. And this angle E1 lies between those two sides that we proved. So that is an inclusive angle. Likewise, for this triangle over here, we proved that this side and this side is equal to the two other sides in the other triangle. And it is the inclusive angle between those two sides. So yes, we do have the inclusive angle. Okay. So what I can say now is I can say, therefore, triangle CED is congruent to triangle GEF, and my reason is SAS. Okay, I want you to keep it like this, SAS, just to show that it's the inclusive angle. All right. So, grade 9s, what I would like you to do is exercise 12.7, numbers 1, 2, and 3 for me, please. Thank you.